Good morning, Atlantis. That's on was for Swanee.
Thanks a lot, Shane. I can tell that was from my wife. We do have that kind of line going. Thanks.
Inside the Quest airlock, spacewalkers Danny Olivas and Jim Riley are in there getting into their spacesuits. Astronauts Steve Swanson and Clay Anderson are inside the airlock as well, assisting with putting on the spacesuits. During the spacewalk, Swanson will be working at the aft flight deck of Atlantis with Atlantis' pilot Lee Archambault to operate the shuttle robotic arm, which astronaut Danny Olivas will be on to access the work site for the blanket repair. The thermal blanket on the orbital maneuvering system pod on the port side of Atlantis is where Olivas will be working to tuck that blanket back down in the area that it's protecting the orbiter, and staple it together using a stapler from a medical kit on board, and also to pin it in place. While Olivas is working on that, Riley will be on the outside of the Destiny laboratory module converting a water vent to a hydrogen vent for the station's oxygen generation system that will be activated inside the U.S. segment of the complex later. That system will take water and convert it to oxygen and hydrogen, keeping the oxygen on board in the cabin, and venting the hydrogen overboard and through this valve that Riley is converting and installing today. After those two tasks, the crew members will join each other at the top of the station where Swanson and Pat Forrester had worked during the second spacewalk to again assist with the retraction of the solar array wing and its panels that are extending to the starboard side of the complex. That retracted about halfway now during initial planned attempts to fold those panels back up and store them inside the blanket boxes so that truss can be relocated later this year to its outboard location on the port side of the integrated truss structure, where the arrays will be again deployed for the final power configuration of the station.
SS Houston, on the big loop, you have a go for depress.
This is Mission Control Houston. The crew inside the station Quest airlock can depressurize the crew lock portion of that airlock now, preparing for today's spacewalk. This is a view from the video camera on the spacesuit being worn by astronaut Danny Olivas, as he is on the space shuttle robotic arm being operated by astronaut Lee Archambault and being moved away from the Destiny laboratory module, where he
About 6 feet out.
got on a foot restraint on the end of the shuttle robotic arm.
For that, JR. Integrity of the surrounding blankets all look to be in good condition. Don't see any other anomalies out here.
Now 1 hour and 3 minutes into today's spacewalk, astronaut Danny Olivas approaching the thermal protection system blanket repair work site on the shuttle robotic arm, hovering over the orbital maneuvering system pod.
Well, about 4 feet out.
Astronauts Lee Archambault and Steve Swanson are at the controls at the aft flight deck of the Space Shuttle Atlantis, maneuvering the Space Shuttle robotic arm.
Okay, take motion out. Okay, motion stop. Okay, I'm at the extent right now. If we need to do anything, we'll need to go in a little bit more. Maybe come aft a little bit more. Do you have that available in the arm? We're going to do some reconfiguring, and then we're going to give that a try then. Copy. Okay, Danny, we're ready to push you in. Would you like to go in towards the work site? This is probably good for some photo documentation. Okay, what I'm looking at here is the integrity of the undamaged blankets is in good condition. There is a bit of a pull away from the tile. I can see a visible gap. However, down at the base of where the blanket attaches to the structure, it looks like it is still in contact, more like a V. Now,
This is Mission Control Houston with the helmet camera view of the repair work site. Now 1 hour and 10 minutes into today's spacewalk.
Okay, most of what I see in the cavity, I see no core pond exposed. I see the silver bar. That is the stretch brownish fibers. You see some torn RTB. The RTB does appear to still be bonded to the bottom of the blanket. And it appears that it stops about midway to what's referred to as the new white-looking tile. Okay, now if you guys can pick that up on WVS or not.
Okay, very nice. Houston, Atlantis, are you receiving EV2's WVS?
Atlantis, we are receiving the image. Thank you.
Okay, pan left slightly. Okay, that's enough on WVS.
This is Mission Control Houston, now 1 hour and 15 minutes into today's spacewalk as astronaut Danny Olivas is documenting the thermal protection system blanket on the orbital maneuvering system pod here. Astronaut Jim Riley is on the outside of the Destiny laboratory module working on removing a water vent on the outside of that component of the space station. After removing that vent, he will install a hydrogen vent, different component that will be used for the oxygen generation system inside the U.S. segment of the complex.
I don't have any light being exposed yet into the cavity.
Okay, we copy. Okay, Danny, go ahead and pan left, and we're getting good WVS. Pan left.
Coming left.
Look down. Tilt down. Good. Keep panning left. That's enough down. Just keep going. That's good motion. Tilt down. Tilt down a little more. Go all the way. Keep going. A little more to the left.
That's about it.
Okay, tilt down some more. Okay, we got it. All right, it all looks good. It's well below.
Okay. Drew, I'd like to yaw to the left just slightly.
Yaw left slightly.
Yes, please. Are we ready to manipulate the blanket on the damage side?
Say again, Danny?
Are you ready for the damage blank manipulation?
Yes.
Here it goes.
As you do it, I'm just going to remind you that you're starting from the fold line and working towards the lifted corner. You flatten the blanket flush or self-flush to the tile OML using your gloved hand.
Now 1 hour and 30 minutes into today's spacewalk, this helmet camera video showing the work being done by astronaut Danny Olivas to tuck a thermal protection system blanket down on the orbital maneuvering system pod of the Space Shuttle Atlantis.
Okay, Pat. I think that's complete.
Nice job, Danny. It looks like that it indeed has got memory such that it stays in place below the OML.
It does. I will tell you right now that it's one step along the seam here. As I forward it down, it felt like the sapphire or the quartz batting on the inside was kind of bunching up, so it's a little bit tougher to push down along the seam here.
Yeah, and you can massage that a little bit. You know, we thought you might have to massage it such that you pushed it a little closer together, but if you need to just kind of massage that area and get it lower, you can.
Okay, I'm pretty happy with what I see.
Okay, we've got a good view of that, and we're happy too. All right, Danny, I think what we're going to move on to is the stapling.
Copy that.
Now, obviously, there's some warnings that go along with that, and so just would ask that you would remember those that we went over with as far as the sharp edges and the distance from the stapler.
Roger that. I'll put that into work right now. The first thing I'm going to do is I'm going to try and open up a groove here.
That's right. You can use the tip of an equipment hook and just separate those edges, and that's to allow to get a lower row of staples in there.
Copy that.
A reminder, Danny, there's 15 to 18 staples in each one of those staplers you're carrying today.
Copy that.
We need at least 8 on the lower.
8 on the lower and 10 on the top, right?
That is correct.
Alrighty, I'll put that in work.
Atlantis, Houston, big leap for EVA.
Go ahead, Megan, for EVA.
Pat, we'd appreciate it if Danny could give us some words about the filler bar and verify that the filler bar is not preventing him from stapling the blankets together.
What I can see here, Pat, is that the staples that I've placed in place appear to be attached to both sides of the blanket. I'm trying to get parallel to the stitching. Looks like I've got one that might be 20 degrees off or so, maybe a couple of 20 degrees off. But it does appear that they're in place. And the tool's a little on the stiff side, and I'm having to use 2 fingers to actually press it down. So most of the resistance that you're seeing right now is related to that and not to the material.
Okay, copy, Danny. Break, Houston, does that answer your question?
Pat, we copied his words. We're checking. And Pat, we'll go with Danny's judgment. If he knows that the believes the blankets are being stapled together, we're good with that.
Copy.
I presently have 1, 2, 3, 4, 5, 6 staples.
Copy, 6 staples.
Seven.
Olivas has completed the lower row, the first row of staples between the seams of these 2 blankets, now tucking the blankets together to complete a second row of staples on the top. This is Mission Control Houston, now 2 hours and 33 minutes into today's spacewalk. This view of astronaut Danny Olivas at the end of the Space Shuttle robotic arm, continuing to put pins in place on a thermal blanket on the Orbital Maneuvering System pod of Atlantis. That to secure the blanket in place after it had been observed folded up. He's already stapled the blanket to an adjacent blanket. And now securing pins as well.
STS-117 pins in. You know, I would make a recommendation, though, from what I see here. This portion here is really high. I'm wondering if maybe we could stick another pin in the corner to kind of help keep it down.
Danny, we'll let the ground look at that, but I think that we probably have got it in a great configuration right now.
Okay.
Atlantis, Houston for EVA.
Go ahead, Houston, for EVA.
Pat, we heard all 21 pins are in. We are happy with the configuration, and you are go to press.
Okay, thanks. Break, Danny. We want to try and get this photo closeout done here with the last little bit of light we have. We've got about 23 minutes, so we need you to get in position with the digital camera.
Working it.
This is Mission Control Houston with a view from the camera on astronaut Jim Riley's spacesuit, who's working on the outside of the Destiny laboratory module, completing the exchange of a water vent for a hydrogen vent for the oxygen generation system, having a little bit of difficulty installing the shield back over that area.
Move you up in the bay and forward in the bay, and at this point we'll be using shuttle coordinates.
So in the meantime, now that astronaut Danny Olivas is complete with the blanket repair, both of them will meet up again to reconfigure for the next major activity of the spacewalk, to swap out tools and equipment for the retraction of the solar array wing on top of the station.
Nice job, Danny. I can see it from here. It looks really nice.
Thanks, man. I heard that the MOD shields are giving you fits.
Oh, it's kicking me.
Good job getting it down, man.
It's not down yet.
Still 2 or 3 yet.
No, not really. We're going to have to release the one that I got in there, that I got in solidly, and reposition it, I'm pretty sure.
Danny, just to catch you up, JR did a really super job getting this whole H2 vent valve task done, and we just got one little thing to do, and it's going to need 2 guys, and we'll get it here at the end.
Copy that.
It's not a one-man test, Danny.
Roger that.
Houston, Atlanta, Sarah, ground 2 for EVA.
Go ahead, CJ.
Hey, Megan, Fyodor just came over and said there was some good news in the Russian segment, and we just want to make sure there's no doubt this P-12 call you made earlier. Can we skip that?
And CJ, that's correct. They did have some good fortune over there with the computers. We are still talking about whether or not they want to demate that connector, and we'll let you know as soon as we have a decision.
Okay, that's great, and we're glad to hear that you're thinking about it.
Latest on the Russian computer systems is that those two computers, the central computer and the navigation computer, both up on 2 of their 3 lanes apiece, following some work by the crew inside the Zvezda service module to disconnect some connectors on either side of a suspect switch. The crew was asked to separate those 2 connectors and tape them up with insulation so that they're completely isolated. The team in Moscow brought down the computers for that work and has reactivated them. They're both working again on 2 lanes. The plan is to let those ride overnight in this configuration until about 12:30 a.m. Central Time tomorrow, Houston. At which time we'll have an opportunity to get some more ground pass data through the Russian ground stations, and the Russians will be able to analyze their telemetry on the status of the computers that have been up and running for that period. This is Mission Control Houston with a view from Daniel Olivas' helmet camera.
There, jaws are out. Good.
As he works with one of the portable foot restraints that will allow spacewalkers to assist with the upcoming task of retracting the 2B portion of the P6 solar array. Here's a look at Jim Riley.
A little bit closer.
This is Mission Control Houston live downlink television pictures from the mast canister of the solar array at the P6 at the very top of the International Space Station. Danny Olivas holding onto handrails on the side of the mast canister, and Jim Riley suspended from Canadarm2, the space station's robotic arm.
Yeah, that's great work there. I'm not so sure you need to go any farther outboard to do all the fluffing, and that'll save a little time.
Yeah, I see it.
Jim Riley using one of the special tools that was developed for this activity, going through what they call a blanket fluff, fluffing the array blankets so that they fold up uniformly.
Retract on my mark. 3, 2, 1, mark it. Good motion.
Good motion.
Abort, abort.
Yep, they all released.
Okay, I agree they all released. We're going to go ahead and power up and do one more thing. I saw them all pop loose just as I called the abort.
Yep.
Danny, are you happy with the right blanket?
I'm happy.
Jay, are you happy?
I'm happy.
Retract on my mark. 3, 2, 1, mark it.
Abort, CJ.
Abort, abort.
Yeah, Brew, take me down about a meter and a half.
Down a meter and a half, then work. Okay, Danny, go ahead and fluff the inner guide wire.
All right.
Okay, that looks good. Danny, stand clear.
Sorry? Would you like me over the right side?
No, yes, look at the right. Can you just look around there instead of going around there?
Yeah, I don't have a good view of the inner guide wire.
Okay, then go ahead and go back over to the other handrail.
Copy that.
Houston, Atlantis out of ground 2. You should see that we're getting good progress.
CJ, we do see that great progress. We had one suggestion. I know you guys have a system, so this is just a suggestion. People down here are talking about maybe fluffing further out to redistribute the folds that are closer to the bottom, redistributing them across the distance, and it's totally your call.
Okay, thanks a lot. We'll discuss that. Okay, retract on my mark. 3, 2, 1, mark. Good motion. Good motion. Abort.
And it's the inner one, I assume?
Okay, stand by, JR. Danny, we're going to need a fluff on the left.
Here it comes. Just released.
Okay, Danny, hold up, hold up. It just released.
Okay, I'm happy with the right.
Jay, are you happy with the left?
Yeah, let's come in a little more. I think a lower release.
Okay, she's powering up. Retract on my mark. 3, 2, 1, mark it.
Motion.
Good motion.
Abort.
Abort.
Hey, Brew, take me on a meter.
Hey, Danny, you can fluff the right, and then we're going to need you to fluff the left inboard.
Excellent, here it comes.
Retract on my mark. 3, 2, 1, mark it.
Motion. Releasing. Looking good.
Looking really good on the right.
Releasing.
Abort, abort. Okay, I called it for left inboard, and it released right as I called it. So we'll go ahead and we're just going to power up and go here.
Happy on the right.
Ready on the left.
Ready on the right?
Ready on the right.
Ready on the left?
Ready on the left.
Tracked on my mark. 3, 2, 1, mark it.
Motion. Looking good. Looking good. Looking great.
Excellent on the right. Oh, stop. Abort. I'm getting a coil up over here on the inboard guide wire. Let me get up here and try and free it.
Okay, Danny, I think we're just going to knock off here. We're almost close to a bay right now.
I have a wrap up here I need to release.
You have the guide wire sticking out?
Yeah, I do.
Okay.
Let me unstag it. There it goes. It's clear. That's clear.
And CJ, everything's looking good as far as the left side. Leader panels and springs are all on the right side of the blanket. All guide wires are taut, no loops, and everything's laying flat.
Copy your report. Go ahead, Danny.
Okay, the leaders are sticking out of the box. All the rays are flat, and ST loops are inside the goalpost. All guide wires are taut.
Copy, Danny.
This is Mission Control Houston with a Jim Riley view of the solar array as sun's coming up over Australia, making final preparations to complete the retraction of this solar array blanket.
Retract on my mark. 3, 2, 1, mark it.
Motion.
Good motion. Excellent.
Looks like a good retraction for you, CJ.
Good retraction. I see nothing protruding from the blanket box skirt.
Okay, we have retracted indications on the PCS. Sonny does.
Sure, I can't see anything.
Copy and concur. It looks good, and we're looking at step 23.7 with the visual verification, and I can read those for you if you'd like.
Okay, go ahead and read them.
Okay, this will be for both blanket boxes and as well as for the crew member in the SM. Verify blankets, correct panel folding, no overhang outside of the blanket box containment.
Actually verified for the left.
No overhang on the right.
Well, this is Mission Control Houston, 7 hours and 9 minutes into today's spacewalk by Jim Riley and Danny Olivas. The job done on the 2B solar array. It's fully retracted. the Falcon officer in Mission Control will complete the last steps of latching the blanket boxes, and then the procedure will be complete. It took 28 commands today, 45 commands in all to retract this solar array and get its blankets firmly into the blanket boxes.
Okay, Pat, I see everything done here. What I've got on me is, I sent one red in with Danny with the ref adapter, so I got 2 reds left on my mini workstation. I've got my 85-foot tether, PGT, rep, and one, and I'm hooked up to Danny's waist tether on my left. I got a small trash bag, BRT with a red.
Okay, we are ready for you to ingress the airlock, JR.
Okay, on the way. Okay.
This is Jenny and JR on their suit-up procedures. They're getting ready for the EVA. We are getting the suits all ready to go, making sure the tools are all configured correctly. You have to pre-breathe oxygen for a while to prevent from having the bends during the EVA. The pilot washable is doing a water fill. We have to take the water that we collect from our fuel cells and use it on station for either drinking water or technical water. And Pat is doing a condensate bag. Okay, we're getting this set up for the EVA, getting some tapes going, all getting lined up, takes a lot of photo TV documentation. Okay, now Alec Kodoff, I am Flight Engineer Expedition 15 of International Space Station, and today I had a chance to work in a log with excellent specialists, the best astronauts from the 117 crew as an IV crew member. So, yeah, I really enjoy to do that. So that's fine. This is Swanee. He was our leader and instructor, and he checked us whole time. And you can see this Fyodor Chikin. He's a commander of Expedition 15 aboard the International Space Station, and he worked very hard with Sonny Williams with visual system and monitoring and arm. And again here, in airlock, looking at a Saper installation. There you are. We appreciate all that jumping in there. the airlock, we put in Jim Riley first, then we backed in Danny Levis. We are giving the last handshakes before we close the hatch on them, making sure everything's set for them.
Okay, this is Brew and myself getting the big arm ready for the later on solar array retraction, in which we would be flying Jim Riley around during the retraction. So here we're just doing the hand controller calibration and making sure that the arm is in the appropriate place for the start.
And then it was time for me, Jim Riley, and Danny Levis to come out the hatch and start the EVA-3. And here you see us coming out of the International Space Station airlock to begin the task for today. We had two big tasks. Danny was working on some repairs on the Ohms pod on the shuttle. While he was doing that, I was replacing a vent on the end of the lab, on the forward end of the lab of the International Space Station today. Forster, I was inside the shuttle doing the IV task where I would read through the procedures and give direction to each of the spacewalkers. It was a challenge today because we had them in two different locations working two different procedures. We also had someone looking out the window monitoring clearance for both the arm. That's Brew Archibald right there. There's a great shot of JR. He was setting up the arm with a foot restraint so that Danny could get in it. That arm was then flown over by Brew and Steve Swanson to do the Ohms pod repair. As Pat said, it was a busy robotics day in support of the EVA. We started out, the first of ours was with the Space Shuttle robotic arm, where we took Daniel Levis from the U.S. lab and moved him over to the work site on the left Ohms pod. And there you saw both JR and Danny getting the arm ready for JR to ingress it. This was a real treat for those in the shuttle today because Jim Riley was working just a couple feet above our head, and so we were able to have a nice close-up view of what he was doing. Now there's a picture right there. You see the silhouette against the Earth. That's Danny on a robotic arm, and that's a really great shot. And then here's what it looks like for him. You're seeing this out of his helmet cam as he moved into location to help repair the Ohms pod. That's the view that he had.
You can see the damage that we were trying to repair on the Ohms pod. You see it's essentially a blanket which peeled up from a corner, lifted up. In addition, you had the adjacent blanket that had been disturbed and actually pulled up. Fortunately for us, the front pile in front of it had not been damaged, so all we had to do was do a repair to the blanket.
Here's a shot of the task that I had today. It's JR again, working on the lab. That it was kind of a unique consideration there with the way that the tools were built that were to take the old one out and put the new one in. Here's Danny again working on the ohm spot.
And the procedure was actually pretty straightforward. Engineers on the ground and a bunch of the folks had developed this procedure. So basically, sticking the blanket in place and then through the use of surgical staples and pins which had been designed actually for another repair, we were able to cinch the blanket down. You can see here, this is actually using a surgical staple like the kind that you find in most hospitals. We have several of these on station as well as on shuttle.
Great picture of the NASA meat ball on the end of the US lab cone.
And as part of the repair procedure, it involved putting these long pins that were designed actually for a different type of repair, but they're high temperature, capable of being able to handle high temperatures. And we inserted these and essentially just pinned the blankets into the tile themselves to prevent them from moving during entry.
This was an integrated team inside the shuttle with robotics going on, observers, and also the ID.
And after the repair, to help the engineers on the ground, we took a series of photographs to allow them to be able to do an assessment on the quality of the repair work to determine whether or not it was suitable. Certainly give them some time to make a decision later as to whether or not that's going to be adequate.
Okay, we're going to show some solar ray retraction, but first we'd like Fyodor, the commander at the International Space Station, to say hi to everybody, and you saw him earlier working with Sunny.
Hi everybody, and I would like to say that first of all we are very glad that expedition STS-117 are with us. Yes, of course, and we are very glad about Sunny because now Sunny can go home, back home, bring home, and have a good meeting with Gorby, of course. It's good. The first is good for Gorby, yeah? And we are glad very well about Clay, our strong boy, our next expedition fly engineer. And we will give him to Expedition 16, I hope, yeah, because now we see in future with hope, and we are ready for continuing our flight so long how we can, yeah? Clay, yes. Thank you everybody, yes, good job, and about your EVA, and welcome to Russian segment for pictures. I have a movie too. We have Jim Riley out on the robotic arm on the left wing, and we have Danny on the mass canister there in the middle that was working the right array. And what we needed them to do was to continue, we call it fluffing, but basically moving the solar panels so that they remained free on the guide wires as we would bring it in. And it was a tedious process. Danny had a tool that was designed on the ground and manufactured by Sunny up here on orbit, and JR had another tool that was put together on the ground, and they ended up bringing this thing in. It was about halfway in when they started, and you can see it here. They've got it all the way down to really just a little over a bay. We had to stop there and have
an inspection done, and once that was complete, we were able to complete the retraction and latching of this solar array, which was a big part of what we had planned to do on this mission. Here you see the end of the solar array retraction. We took it down about a half a day at a time to make sure that everything was aligned properly. And when we got close enough, we had to wait and make sure that the latches and everything would be ready to close it down permanently. As we did all this, we were working on the shuttle flight deck and in the station with 2 computers. And Sonny would power up the motors to cause the retraction, and then we would send abort commands to stop and check out the work and make sure everything was going according to plan. Next thing is there in the... Here you see the view from JR's helmet cam of Daniel Levis, and you see the solar array is folded up nice and neatly. And this is about the time we were getting ready to come on inside, and everybody was enjoying the views at the same time. Okay, so next thing was that we had to still get the crew back inside, the EV crew members. The EVA went a little longer than planned, but it was well worth it. Sonny was still monitoring arm clearances from the shuttle pilot window. And here you see Clay and Brew and Swanee, with Swanee at the controls flying the big arm away from structure and getting everything set up in the proper configuration. You can see they had excellent views, plus Sonny's calls at the shuttle pilot window to make sure that we were maintaining the proper clearances. Okay, and finally, after a great EVA by JR and Danny, we sent the crew back inside the space station airlock with the tasks accomplished. It was a wonderful feeling, but the job wasn't done. Even though they're back inside the hatch, you still have to get the crew members out of their suits, and Swanee's going to finish up that story. This is Oleg right here. He's repressing the airlock. You can see it takes a good number of people to actually perform all these tasks. It was nice to have everybody helping out. It made it go much more smoothly that way. Let's look into the hatch. You can see Danny right there and JR up and to the right. Now we're opening the hatch. And a good handshake for a job well done. We are moving Danny out of the airlock. We'll have to get his safer off, just like we put it on before. There's JR, if you got his helmet off, very happy. And Danny after his helmet off. And that's it for today. Thanks.